Array quality control, or QC, is very important prior to any further expression analysis. It is at this point we are made aware of any technical disturbances that might adversely affect our data analysis. IBD generates a comprehensive QC report, including all the necessary QC metrics associated with your microarray platform of choice. These metrics are divided into 3 tabs with an explanation for each one of them on the left-hand side panel. For this Affymetrix dataset, the first QC metric that we will look at is the perfect match mean. We can observe this based on independent arrays or collectively as a group. These are the other QC metrics that are related to the signal intensity across the arrays. The internal labeling and hybridization controls also have a graphical representation and allow us to determine the overall technical reproducibility across the arrays. The correlation plots represent the second tier of QC that IBD offers. The ability to assess the correlation between different samples allows us to determine the prospect of outliers amongst the biological replicates within the groups. By specifying on the table of samples, it is easy to go through and assess the correlation between individual samples. The signal intensity of the arrays can be observed in the QC tab as well. In order to get a better indication of inter-array signal variability, we can increase the number of bins on the x-axis. In this dataset, no obvious outliers have been detected thus far, and the signal histogram is concurrent with that. To make the data comparable between arrays, it is necessary to correct for the systematic, technical biases which are similar over a set of measurements. Therefore, array normalization is essential for all microarray experiments and should be performed prior to the differential expression analysis. IBD employs a within-array normalization strategy where arrays are normalized independently and expression value intensities are made consistent within each array. For Affymetrix, the user has the option to perform quantile or scale normalization. For normalization strategies for other platforms, please refer to pages 146 to 174 in our manual. Once the arrays have been normalized, we can perform a differential expression analysis on our groups. For further information and tutorials, please visit www.integromics.com.